of the most important topics, encryption. Whatever text you see here are all in English, right? You can call this plain text. Encryption is a process through which you will transform this into some other form which you cannot directly read like this one. And that other form is generally referred to as a ciphertext. And you use another process called decryption to bring back the plain text from ciphertext. So the plain text is converted to a ciphertext through encryption, and the ciphertext is converted back to plain text through decryption. When I was a kid, without knowing anything about computer science, we used to do a little bit of encryption, decryption and all. Last day, I was watching my daughter play with her friend. Both of them were communicating with each other through a kind of encryption. So basically, they were converting each of the alphabet into an alphabet 2 or 3 times ahead of it. For example, instead of A, they will write C. Instead of C, they will write E, and so on. And when they receive the letter, they will convert C with A, E with C, and so on. That is also a form of encryption and decryption, right? And in today's world, one difference is the algorithms that are used to do encryption and decryption are kind of popular. So when kids were playing, only people who knows about this encryption and decryption methodology were those kids only. But in our case, we have a very good algorithms, and these algorithms are all published. So everybody knows about these algorithms. So if you encrypt using an algorithm, anybody can encrypt and decrypt that message, right? That is why in computer science, we also use something called as a key for encryption and decryption. So this key will be known only by two systems that are communicating. So as long as nobody else knows the key, your encryption and decryption are safe. So consider a real world example from an older era where these mobile phones or emails or internet was not present. So how do you use to communicate during those times? It was through letters, right? Imagine that one of the beautiful princess wanted to send a letter to one of the handsome prince. Some kids or somebody else will be carrying that letter, and they want the contents of the letter to be secret. One way is they can use some letter replacing encryption or decryption that we were using before, but somehow they have to communicate this thing with the other person, right? So these two people who are communicating will need to communicate the letter replacing logic or the encryption and decryption methods with each other. So can they write these things also and send to the other person that from next letter I'll be using a letter replacing 2 characters ahead or 3 characters ahead? Then people who are carrying will also get to know the logic, and then they will be also doing encryption and decryption, right? So in real world also, if 2 people or 2 systems are communicating using encryption and decryption and uses only one key, which is also called as a symmetric encryption, then how do you transfer the key? How do you share the key between each other? If you send the key first, then similar to our kingdom example, people who are carrying or people who are standing in the middle may get the key. So this is also called as man in the middle attack. So that is why engineers have come up with asymmetric encryption, which uses 2 keys. Okay, in symmetric encryption, you have only one key that is used for encryption and decryption. And AES is a popular symmetric key algorithm. And with asymmetric keys, you have 2 keys. With symmetric keys, you have a combination of public and private key pairs. So pair means 2, right? So everybody will have a pair of keys. One is called a private key and one is called public key. Private key is something that they will hold with themselves, and public key is something that we will share with the world or share with the other person. And with asymmetric encryption, you can encrypt using one key and you can decrypt using the other one in the pair. For example, if you are encrypting using the public key in a pair, you can decrypt using the private key in that pair. If you are encrypting using public key in that pair, you can decrypt using private key in that pair, and vice versa. Before we proceed, let me ask you one thing. How many of you know and understand these terms called confidentiality and integrity? Confidentiality means if I want to send a message to somebody, nobody else should be able to read it. Integrity means when I send a message, the recipient should be sure that I have sent that message. Confidentiality means if I want to talk to, say, Kavya here, I will need to somehow make sure that only Kavya reads my messages. So now tell me, if I need to send a message to Kavya and I need to make sure it is confidential, meaning nobody else should read it, which key will I use to encrypt that message? There are 4 options. Hartin's public key, Hartin's private key, Kavya's public key, Kavya's private key. Everybody should answer. Otherwise, you will not get the invite for next session. If you don't know, just make a guess. My goal is confidentiality here. I need to make sure that only Kavya should read the message. Nobody in the middle should be able to read it. So let me take one by one. Let us take the first one, Hartin's public key. So here I am sending a message to Kavya, and the only person who should read should be Kavya. So if I encrypt any message using Hartin's public key, which is the only key that can decrypt that message? Hartin's private key, right? And will Hartin give away his private key to anybody? No. So definitely Hartin's public key is not the answer. Because you should not be giving your private key to anybody. So now let me go to Hartin's private key. So if I encrypt using Hartin's private key, who can read that message? The whole world has my public key, right? Or they can get my public key because it is public key. So will that message be confidential? No. So Hartin's private key is also not an option. So what about Kavya's private key? Can I encrypt with Kavya's private key? No, right? I don't think Kavya will give her private key to me. She shouldn't be giving to anybody, right? So what is the only thing that is left? It is Kavya's public key. So Kavya's public key is with everybody. So I also have it. So if I encrypt using Kavya's public key, who is the only person who can decrypt it? It will be Kavya. So now let me ask you another question to make sure you have really understood these things. Now my goals have changed, or our goals have changed. So I am sending a lot of messages, and Kavya is having doubt that whether these messages are actually sent by Hartin or not. Now we don't care whether the world is seeing or reading these messages, but Kavya wants to be sure that the message is sent by Hartin only. So with which key will I encrypt now? So again, same options: Hartin's public key, Hartin's private key, Kavya's public key, Kavya's private key. As the goal is integrity, and Kavya needs to be sure that this message is coming from Hartin. It is Hartin's private key, right? Who is the only person who has Hartin's private key? It is Hartin. So if somebody is able to decrypt that message using Hartin's public key, then they can be sure that, okay, this message was created by Hartin only. So this concept can be used in digital signatures and all. And you may be also using a combination of these two keys for getting both confidentiality and integrity. We are not going to go deeper into this subject more. But at least if somebody asks you, what this encryption is, or what this decryption is, what symmetric encryption is, and what asymmetric encryption is, and how this public-private key pair work, will you be able to answer? So now we will look into HTTPS. We saw what HTTP is, right? So HTTP can be attacked, and people can get the message, and it does not make that a secure approach. So problem with HTTP is a man-in-the-middle attack that we discussed using our Kingdom example. It is based on TLS protocol. It's a newer version of SSL. TLS handshake happens between this client and server. And TLS handshake also uses Ssl certificate signed by certificate authority using its private key. Don't worry if you have not understood all these things. We will see them in bit more detail now. So HTTPS uses TLS, and TLS has a handshake mechanism. So how does TLS make sure that the communication between two parties, let us say a client, browser, and server, are secure? The S in HTTPS stands for secure, right? One option was to use a public key, private key combination like we discussed earlier. But tell me one thing from the previous slide. Which of these is faster, symmetric encryption or asymmetric encryption? It is symmetric encryption. Symmetric encryption is faster than asymmetric encryption. So which one should we prefer, symmetric or asymmetric, when we have a chance? A faster one or a slower one? Faster one, right? Whenever you have a chance, you should go with the faster one. So which is the faster one? Symmetric. For your communication over internet or our Kingdom example, they can definitely communicate with the symmetric encryption without any problem. What was the only problem that we faced? It was about exchanging the key, right? So if two people know the key already, then they can use a symmetric encryption to communicate between each other, right? After sharing the key securely, even if you use a symmetric encryption or even if you use asymmetric encryption, you will have a confidentiality, you will have integrity, because only you two have this key. Clear until now? This knowledge is essential for understanding HTTPS. In summary, if you can somehow share the key securely, then you can use that key to do a symmetric encryption, which is much faster than asymmetric encryption. You should always look for better performance when you have a chance. Sometimes you'll have to make a trade-off between performance and security. That is another story. But here, if you have already shared the key securely, then you can decide whether to go for symmetric or asymmetric. Both will work. But symmetric is preferred because it is faster. So considering all these things, how does a TLS handshake work? So when a client communicates to server for first time, client sends a client hello. So when a client sends hello, it will create and send a random number. And then server will send back a hello, sending server's public key with an Ssl certificate. Forget about Ssl certificate for time being. So client sends a hello to server with a random number, and the server sends a hello back to client with another random number, and then with the server's public key inside a Ssl certificate. And then client will now send a secret called as pre-master secret. This time client will encrypt using server's public key. So who is the only person who will be able to decrypt it? It will be the server. So the client and server uses the pre-master secret because client generated and sent to server, right? So both client and server has all this information. It has all these random numbers, and most importantly, it has this pre-master secret. So both client and server has pre-master secret, and they will use this to generate a session ID. So this session ID further can be used as a symmetric key for the current session. And as a final step, server and client sends an encrypted message to each other using this session ID to finish the handshake process. In summary, server and client uses asymmetric encryption to create a key that is then used for communication using symmetric encryption. Does it make sense? There are variations of this, but from a systems design perspective, this knowledge is enough. If you are working in a security field, you can definitely explore more. So we left one topic from this slide, which was Ssl certificate. Imagine that the client is sending hello to server, and server is directly sending servers public key. What if man in the middle attack happens and somebody else captures server's public key and replaces it with their own public key? Client will think that, okay, I have got server's public key. And then client will encrypt using middleman's public key, thinking it is server's public key. So who can read those messages? Man in the middle or the server? Man in the middle, right? So there should be a way for client to be sure that whatever I have received as server's public key is actually server's public key. So somebody with authority has to certify that this public key belongs to this server and this is a valid public key. And there are many such certification authorities. So as an assignment, you can find out popular certification authorities and share it as a comment. For the purposes of testing, you can also assign certificates, and that is called as a self-signed certificates. But you will get a warning that, okay, these are self-signed, these are not coming from a certification authority. Clear? We will have other one-on-one sessions for networking, IP addresses, cyber